Okay, welcome back. So we have been discussing SRS and we will finish discussing most of it. Okay, and rest of it we'll finish discussing in the next class. Okay, so we'll finish discussing this at least. This is what we have been discussing, like the single port SRS. Okay, I have not even discussed multi-port SRS as of now. Okay, the notion of multi-port and SRS will come a little later. Okay, so that's what we'll start doing. That we'll first finish discussing this. Okay, now so we have understood SRS, the notion of hopping, how hopping gets enabled. Okay, and typically how many hops will be required to sound out the complete bandwidth. Okay, to sound out the maximum sounding bandwidth. Okay, right. So and I'm going to put everything together. Okay, and then understand like how standard has defined this framework. Okay, so we have actually understood most of it. Now let's put together everything. So what are we saying here? Okay, so what is this BSRS? You look at this. We looked at this BSRS. BSRS is 0, BSRS 1, 2, 3. We picked up these columns. Okay, but I did not specifically define what each of this BSRS tells us. Okay, right. So now if let's say what is this? This is the maximum sounding bandwidth, which is MSRS 0. Okay. Now what are we saying here? This BSRS determines the number of PRBs, okay, within the actual sounding bandwidth, okay, that are sounded in each hop of a hopping cycle, okay, which is given by MSRS B for B is equal to BSRS. I'll give this, we'll discuss this in detail now. What values BSRS can take? It can take 0, 1, 2 and 3, right? Okay. What am I saying here? So look at this. What are we saying? See, MSRS is 0 is the maximum, correct, which the base station is interested in sounding. Okay. Now, what are we saying? What are we writing over here? Don't get carried away by this B is equal to BSRS MS. What am I saying here? So, what values BSRS can take? 0, 1, 2 and 3. Right? Okay. So, what does that mean? Okay, that the actual sounding bandwidth, okay, within that actual sounding bandwidth, how much you are going to sound out in each hop, okay, right, that is decided by BSRS. Fine, okay. Now, so this is, if let's say BSRS is 0, okay, which is this column, correct, okay. So, or let's say BSRS is 2, I am picking this, okay. So, bandwidth per hop is 12, right, okay, that is what this bullet is telling. The BSRS determines the number of PRBs within the actual sounding bandwidth that are sounded in each hop of a hopping cycle. Okay. So, how many PRBs will be sounded out if BSRS is chosen as 2, 12, right. So, bandwidth per hop is 12 PRBs, okay, right. Now, what I said, if B hop is 1, correct, okay. So, now everything will come together. Okay. The actual bandwidth over which the hopping occurs, okay, is basically what have we said, okay, if B hop is 1, what will be the actual sounding bandwidth, okay, over which the hopping occurs is 24 PRBs. I have said B hop is 1, BSRS is 2, okay, maximum is SRS 0. Understand this, that maximum which needs to be sounded out is 48. Actual is in basically actual bandwidth over which the hopping is occurring is 24 PRBs, because I have set B hop as 1. Okay, if B hop is 1, what happens? Then SRS gets set as 1, okay, which is 24 PRBs. Okay, right. So, what is happening here? BSRS is 2, B hop is 1, okay, right. Now, B hop is less than BSRS, right. So, hopping will happen, correct, okay. And how many hops it will take to sound out the complete bandwidth? So, B hop is 1, okay, that's how I have set it. Okay, so the actual bandwidth over which the hopping occurs is equal to MSRS1. This is the actual bandwidth over which the hopping will occur. Over how many PRBs? That is 24 PRBs. Okay. Now, what is this MSRS0 is how much? 48, right? Okay. So this is the maximum. Okay. B hop is 1. So this is the actual bandwidth over which the hopping is happening. Okay. So what I am saying here, maximum is this much, but I am sounding as a part of this hopping pattern, I am sounding out this actual bandwidth, which is only 24 PRB. Okay, right? And what have I set this BSRS as 2? What is BSRS defining? Number of PRBs within the actual bandwidth, this is 24, that are sounded in each hop of a hopping cycle. Okay, right? So the actual bandwidth is 24, hopping bandwidth is 12, right? Which is set by choosing BSRS as 2, right? That's what determines, okay? BSRS determines the number of PRBs within the actual sounding bandwidth. Actual sounding bandwidth is 24 PRBs, right? This is actual, not the maximum, okay? There is maximum, there is actual, then in that actual, how much is sounded out in each hop? That is decided by BSRS. Right? Okay, fine, clear? Okay, so what is this now? Okay, so this is in each hop. Okay, what will happen here is that actual is 24. Okay, hopping cycle will complete in basically how many it will require. What are we doing? Actual is 24. In each hop, we are sounding out 12 PRBs. Okay. So for sounding out the actual bandwidth, how many hops you will need? 2. 24, right? Where is that 24 coming? Yeah, right? B hop is set to 1. What is B hop tells you? B hop tells you the actual bandwidth. Correct? B hop is 1. That will give you MSRS. It'll become 1. Okay, so the actual bandwidth, if you look at MSRS1, that becomes how much? 24 PRBs, right? Fine. Okay, this 24 PRBs will be sounded out in how many hops? Okay, that is decided by BSRS. That is, how much is BSRS? BSRS is 12. Correct? Okay, 24 is actual, 12 you are sounding out in each hop. How many hops you will need? 2 hops. Fine, correct? Okay, so that's what is this. Okay, so this is an intricate relationship. It takes some time to crystallize things. Okay, so now if I set B hop as 0, correct? Okay, now what will happen? Actual bandwidth. So now actual bandwidth is equal to the maximum bandwidth. Right? That's how you are going to, in this case, you are sounding out the maximum bandwidth. Okay? So what am I saying? If B hop is 0, actual bandwidth over which the hopping occurs is equal to the 48 PRBs. Now how many hops you will need in this case? That's the formula. Okay? Okay, so hopping cycle will complete in how many hops? In each hop you are sounding out 12. Actual is 48, you will need, that's the formula, N1 into N2, okay. N1 into N2 is 4 hops, okay. So there is a generic formula, I will give you that, sorry. Okay, so how does this come? That's what you are asking, okay. In general, a hopping cycle completes in, this is product, pi, and it runs from where? B is equal to B hop plus 1 to BSRS. Look at these values, okay, right. So let's look at this example, okay. What was B hop? 0. So B will run from 1 to, what is BSRS? BSRS is set to 2. What comes here? This will run from 1 to 2. So what you will have? N1 into N2, okay. So that's how it works, Okay, you see it's a little involved. Okay, so you have the notion of maximum sounding bandwidth, you have actual sounding bandwidth, and the bandwidth sounded out in each hop. And let's move on from here. So we'll take one or two more examples, and then it will become clear. Okay, so again the same, this table remains same. Okay, so this we are considering intra and inter slot frequency hopping. Okay, taking examples to understand it better, that's all. Okay. Now, so this case 1 and case 2. Okay, so what is this? SRS with B hop is equal to 0, right? So the actual bandwidth, sounding bandwidth is equal to the maximum sounding bandwidth, right? Okay, correct. So fine. So B hop is 0, and what is BSRS? Is I have set it to 2. Right, so we just did this example. How many hops it will need? 4, right? And no repetition. Okay, so what is happening here? Here you see this, it is basically being done over, this is one hopping cycle. So in one hopping cycle, so you need 4, this one. It'll be done in 4 hops. Okay, but so this is basically you are hopping, where are we hopping? This is one hopping cycle. Okay, so we are hopping over, so there are 4 hops. Okay, why they are not showing up? Look at this, this is offset. You look at this gap. Okay, so this is one hopping cycle, right? Okay, correct. So I was getting confused that both of them are same. They are not same. So this is one hop, this is 13 symbol, and this is 14 symbols. Okay, right? So you have 4 hops. Okay, so SRS with B hop is 0 and BSRS is 2. Okay, so how many hops we'll need? That's the example we took in the last class, in the last slide. 4 hops. How many hops we are taking? This is first hop, this is the second hop. Here, this is coming over here. Okay, 13th and 14th symbol. Right, again 13th and 14th symbol. Right, so you are doing this, you are sounding out this channel in 14 hops, correct? In 4 hops, okay? Right, that's how we have set it. And the repetition is 1. So this is one wherein you are sounding out the complete, this is one hopping cycle, this is, the next one begins. So when I say this hopping cycle, so over this is one, this is the beginning of the next one, that's what I am saying. Okay, don't get confused by that, this is also part of this hopping cycle, no. Okay, hopping cycle consists of these 4 hops, right? Okay, the next hopping cycle will consist of again next 4 hops. Okay, fine. Now here, so same BSRS is 2, but we have set a repetition factor of 2, right? So what is happening? We are repeating, that's all. Okay, so this again, so in the hopping cycle is going to increase because we have allowed repetition of a factor of 2. Okay, fine. And so the number of hops required to sound out the maximum bandwidth is 4. That's all, right? Okay, so this is an example. Okay, we take one more example. Okay, to make things more clear for us. Okay, so this is inter-slot hopping. Again, like the figures were drawn by different students, so different colors. That's all. Okay, so the same table. SRS with B hop is equal to 0 and BSRS is 2. Right. So what are we doing here? Okay, so the number of hops required to sound the 48 PRBs, okay, is 4 hops. Okay, so again this is a slightly different example. Okay, so again you require 4 hops, so we are doing it in 4 hops, 1, 2, 3 and 4. Okay, in the case 2, what's happening over here is, okay, that this same, so we have said B hop is equal to 1, B hop is equal to, so what will happen, and BSRS is 2. Okay, there is this NRRC which is coming. Okay, correct. So what is this, what will happen here? 1 second. So in this case, B hop is 1, BSRS is 2, okay, and NRRC is 0. So B hop is 1. What happens when B hop is 1? Okay, so you will have the actual sounding bandwidth is 24, not 48. Okay, so now you see the difference between, this will basically make the difference clear between the maximum sounding bandwidth and the actual sounding bandwidth. Okay, So the maximum sounding bandwidth is 48. Actual sounding bandwidth with B hop is 24, right? But you still need to sound out the maximum sounding bandwidth, correct? Okay, right? So if I am setting B hop to 1, what is actual sounding bandwidth? 24, right? Fine. And BSRS is 2. BSRS is 2, correct? So what are we doing? Okay, so in each hop, we are basically sounding out 12, right? Okay, so you see this. Okay, so this is, we are sounding out this 12, okay, correct? And so this is basically, and what are we saying over here? This NRRC is set to 0, okay? What this NRRC set tells us is as follows. I'll decide the position of actual sounding bandwidth within the maximum, okay? So what did we say? Okay, there is maximum sounding bandwidth, there is actual sounding bandwidth, okay, right? So, and within that actual sounding bandwidth, we are sounding out the bandwidth in each hop, 3 different like hierarchies, okay, this is the hierarchy, okay. So, now what is happening? Actual sounding bandwidth is only 24, but you need to sound out the maximum sounding bandwidth also, right? Correct? How does that happen? That is configured by NRRC. This is the parameter which was missing till now, okay. So what is happening when NRRC is 0? So this factor NRRC gives the offset of actual sounding bandwidth in terms of multiple of 4 PRBs. Okay, let's look at this, okay. So B hop is 1, actual sounding bandwidth is 24, right? When NRRC is set to 0, which part of the bandwidth you are sounding out? The bottom half. Okay, because the total sounding bandwidth is 48, right? If you set NRRC to 0, right, what does that mean? The offset for the actual sounding bandwidth is 0. If NRRC is set to 6, what will happen? It will move by 24 PRB. So that's the later half, right? Okay, so this NRRC tells us the actual bandwidth, so this B hop, right? Okay, so the actual bandwidth belongs to which part of the maximum sounding bandwidth, right? Okay, that is decided by NRRC, and this gives the offset in terms of multiple of 4. Okay, so here this is the complete configuration. You set NRRC to 0, right? Okay, we have set B hop to 1, correct, which means the actual sounding bandwidth is 24. Maximum sounding bandwidth is 48, but so you need to sound out the maximum sounding bandwidth, right? Okay. Now so how will you do that? In the first half, you set NRRC to 0, so that you sound out the bottom part of the maximum sounding bandwidth. In the second part, okay, you set the NRRC to 6, so that you sound out the second half of the maximum sounding bandwidth, because this gives the offset in terms of multiple of 4. Okay, so 6 into 4, 24. So you move on to the second one and do the repeat operation, whatever you are doing here, right? Okay, so if you look at it, how have we done all this exercise? I could not have told you to begin from here. So I've given you information in parts, right? Okay, MSRS 0, B hop, MSRS 0 tells us the maximum sounding bandwidth, B hop tells us the actual sounding bandwidth, okay, right? But you need to sound out the maximum sounding bandwidth, okay. And how do you do that? How are they related? They are related using this basically. So which part of the maximum sounding bandwidth you will sound out using actual sounding bandwidth is set by NRRC 0, right? Okay, and within that all these hopping patterns are defined, right? Okay, so and we know the formula that how many hops you will be able to complete the whole operation. That's what we have discussed, correct? Okay, so this is how this whole SRS business works, okay, fine. So, and if you look at it, that we have only discussed that there is only one port SRS, in the sense that, like, if there is a multi antenna user, okay, how will it transmit multiple ports? We remember SRS can be needs to be transmitted for multiple ports also, okay, right. As of now, if you look at this, what have we said? There is a SRS has a COM structure, correct, and that COM structure can be used by different users, okay, correct, and each user will be offset will use a different COM, okay, so that different user can sound out the bandwidth part simultaneously, right. One user is using one COM, other user will use the other COM with an offset, okay, right, and that's how different users will sound out the bandwidth, okay, uplink bandwidth. Now, so let's move on to see how this multiple ports can be sounded out using the SRS, but before that, this was missing. So NRRC has a configurable range of 0 to 67, because why? Offset can, if the complete bandwidth is being sounded out, right, okay. So if I say that, what are the maximum number of PRBs which can be sounded out together? 68 into 4, okay, 272, that's the number which was there, right. So it has a range like that, okay. So till now we have discussed SRS for a single port transmission, okay. We will now discuss SRS for multi-port transmission, okay, and that will bring us to a closure. I will discuss only little bit today, and then we will continue discussing this in the next class, okay. What are we doing here? This we have finished, okay. We are going to discuss this SRS for multi-port transmission and how are they defined, okay. So let us look at this and let this figure what is being shown here, okay. Now this antenna port for SRS, okay, usual port numbering, okay, so it starts from 100, okay, and goes up to, like, how many maximum SRS ports can be sounded out? 4, right? SRS are designed for that. So they are numbered starting from 100, okay. What are we saying here? That's the first key information I am giving you. This multiple ports are all multiplexed onto the same COM, okay, right. And what do we mean by that? Okay, so we have so what is this? This is a 2 symbol SRS, and this is one COM. You forget this for some time. This is another example, okay, right. What am I saying here? This is one COM, right, okay, correct, and what this bullet is saying, all the ports are multiplexed onto the same COM, okay. What do we mean by that? You remember DMRS, okay. How did we multiplex different port DMRS? We use something called code division multiplexing, right. They were defined on the same resource elements, but what did we do? How did we multiplex? We used code division multiplexing, frequency division multiplexing. So what are we saying here? The different ports of SRS will use the same resource elements. That's the constraint which is being imposed by the standard, okay, right. So multiple ports are all multiplexed onto the same COM, and so the number of antenna ports denoted as NAP for an SRS resource may be configured as 1, 2 or 4, maximum of 4 SRS ports, okay, right. On the left, on this, okay, what have we done? All the 4 ports are mapped to the same COM in each OFDM symbol, and this COM has a COM spacing of 2. This is a COM spacing, right, okay. It can have 1, 2 or 4, right, okay. So the COM spacing of 2, okay, right. So all 4 ports are mapped to same COM in each OFDM symbol with a COM spacing of 2, and so how will it be mapped, okay, right. So what are we saying here? That on the same subcarrier we will have to create 4 different ports, okay, right. You see this, all these green color, what is this green color telling? 100 to 101, 2, 3, okay. All of these ports are mapped onto the same port. How are they created? That we will discuss. Some kind of code division multiplexing has to happen, like it happened for the DMRS, right, okay. And here Look at this. On the right, different port pairs are mapped to 2 different comms, each with a spacing of 4. Look at this. Okay. On the red one, how many ports are mapped? 2 ports. And on the green one, how many ports are mapped? 2 ports. Okay. How are they? So we'll have to create some kind of code division for that, so that you can differentiate these 2 ports. We have to make them orthogonal, these 2 ports, using some code division multiplexing. Okay. Here again, there will be 2 ports. Okay. We'll have to again differentiate them using some kind of code division multiplexing. So we'll have to, here for this example, we'll have to create 2 CDM. Just for an example, I'll tell you what exactly they are, how they are multiplexed. Okay. Right. Remember this DMRS, if 2 ports are there, you have to create a sequence like this, +1, +1, +1, -1. Right. That's the orthogonality. Something similar needs to be done, but in a different way. Okay. Right. Here how many? Right. You will have to create 4 different sequences. We did that, right? Okay. We understood that in detail for DMRS. Okay. Correct. So what the key point to take away from here is all the 4 ports are mapped onto the same resource elements over here. It's the same COM basically. Okay. Here on one COM, 2 ports are mapped, on another port 2 COMs are mapped. Here on the same COM, all the 4 ports are mapped. Okay. And how are they multiplexed? We'll see that later. Okay. Right. So I'll stop here. Okay. So what are we saying? In 5G NR, all antenna ports are sounded in every OFDM symbol of the SRS resource. Okay. So you see this in each symbol, we are actually sounding out all 4 ports. Though we are defining over 2 symbols, here 2 ports are defined, here 2 ports are defined, here 2 ports are defined, right? Okay. So what is it saying? All the symbols will basically sound out all different ports, okay, wherever they are defined. Wherever the SRS is defined, in whatever symbol SRS is defined, okay, all the OFDM symbol will sound out all the antenna ports. Fine? Okay, that's this last bullet. What are we saying? All antenna ports are sounded in every OFDM symbol of the SRS resource. Okay. So we'll stop here. We'll continue discussing this in the next class. Okay. Thank you.